All right, so we're going to look real quick today at what a decision matrix is. So on the screen right now is the design brief that we looked at just a little bit ago. So the design brief, again, is just that problem statement, and it's what describes what it is that you're going to design. So what we're going to talk about today is called a decision matrix. So a decision matrix is a way to quantitatively assign priority to certain values, usually these criteria and constraints. But basically, a decision matrix is just a way to quantitatively, which means with numbers, make a decision. So that instead of just relying on gut instinct or what you think or feel is going to be the best solution, you actually get to create a solution based on numerical values that you assign. So an example of a decision matrix for this design brief is right here. So let's talk about what this is. First of all, we have a nice little chart. The leftmost column are simply our various design ideas. So for example, this is design idea number 1, and we'll actually write in that it is a design idea. And that's what these are, is as you're working through brainstorming, coming up with ideas to develop, these are your brainstormed ideas. How might you solve this? Across the top, in this case, we have our 4 main criteria. So if you come back up here, we've got the physical space solution, so space requirement, the power solution, so power, the repairable solution, so repairability, and then budget, so cost. So each of these different criteria has a number assigned to it. But in order to know what those numbers mean, you have to have a key. So every decision matrix should have some sort of a key that just lets you know what each number represents. And in our case, the key is right down here. It simply says that our key, everything is ranked 1 through 5, 1 meaning a poor option or 5 meaning a good option. For example, if we're talking about cost, a 1 on cost indicates a very expensive project because that's a poor choice. And obviously, the cheaper you can do something, the better. So a 1 on cost means it's a very expensive project, while a 5 would indicate that it's very cheap. So looking at this, we've got design idea number 1, cost is 2, which is obviously means a fairly expensive project. Space requirements of 5, which means that's a good option. So that's obviously going to fit inside that space, if not actually be a little smaller. The power is a 1, which means a very bad option. So that probably indicates that whatever this design idea is, it requires something more than just your standard outlet. And then repairability also gets a 1. So since that's a poor option, what that would mean is that maybe this one actually would require an outside repairman. And then we add those up and we get a total of 9 points. Design idea 2, well, it's got a cost value of 4. So that means it's fairly inexpensive. Space requirement 4 means it's probably going to fit in that space. The power is 3. So we don't know exactly what that means because obviously these design ideas haven't been fleshed out, but it might mean that it'll plug into a standard wall outlet, but you also need a power converter to adjust that 110 AC outlet to something else. So there's something going on there that we just don't quite know. Repairability, a 2, again, it probably requires a little bit more out there. Okay, total of 13. The last one, design idea 3 has a cost value of 2. So again, a little bit more expensive. Space requires a 1, poor option. That means maybe it's way too big or won't fit in that exact space. Power is a 5, so that must be great. So that probably means, hey, it just plugs right into the wall. And repairability is a 4. That means, well, chances are most of your time your students could just repair it in-house. And you get a total value of a 12. Now, this is where the fact that you have to have a key is important. So as long as these are consistent, saying, for example, in this case, that a low number means a poor option and a high number means a good option, it means that when you add these up, the highest result is the one that you should probably go with. So in this case, that was our design idea number 2. Now, obviously, this design idea, whatever it is not perfect, but it does do the most for us when it comes to finding and meeting these criteria and constraints. So this is why make sure your key is always consistent and spell it out. So what's a bad choice? What's a good choice? You don't want, for example, the number 1 on cost to indicate low cost, but then the number 5 over here indicates that it fits perfectly. So you have to make sure it's consistent across your entire decision matrix, which is why you always want to have some sort of a key. And having a key is also important for somebody else who just walks in and looks at your matrix, and you need them to be able to interpret it in the future. So the decision matrix, again, is just a quantitative way to define how to make a choice. We take the data we have, apply it numerically, and it gives us a reason to pick design idea 2 over design idea 1 or 3 instead of just guessing, oh, we think this one's going to be the best or we think it might work well. It actually gives us a way to state this is which one we think will work best and this is why. So that's something what you always have to consider with a design decision matrix, is that it is explaining why you are making a choice instead of just going with your gut.